Hello, my name is Mustafa. Welcome to Lab101. I will be talking about chi-square tests in this video. Let's see the assumptions for chi-square tests. These are not like really assumptions compared to t-test and ANOVA or regression tests. These assumptions are like more if you can do the tests or your data is okay. You wouldn't reject your if it's parametric or non-parametric. You wouldn't decide according to these. So let's see. You you need two independent samples, two categorical independent samples at least. You can have more than that. The observed sample data is frequencies count of data. So the thing that you measure is number of trials. So you need to have multiple trials if you want to do chi-square test, and the frequency of each cell, expected cell, must be one. It's generally one, so you don't need to worry about this one. Variables. So two independent categorical variables. It uses dichotomous system, so it's 1 0. Yes or no, exist or doesn't exist. So dichotomous means you have two outcomes, no more, no less. It requires, as I said, multiple samples to make it. So give me some. Let me give you some examples. Does it? Let's start with an easy example. Does it smell nice when it rains? Does it smell nice when it rains? Or does the two genes? So you would have two independent variables like this one smelling nice and raining, and these are two categorical variables because rain you would have one and zero. Yeah, so dichotomous system. You would does it rain or it doesn't rain? Does it smell nice or does it smell bad? Similar with this one, two genes on the same chromosome. Does the chromosome exist or doesn't exist? Since there's two, it's two categorical independent variables. Two species of plants or other species animals are seen together. Seen together, one seen together doesn't seen together. I will explain with the Excel better. So you have one condition and another condition, and you have the dichotomous system here. So you take one measurement. This can I will explain better with these examples as well. You would take one measurement. You would put marker here. Assume that this is a marker, and you would make another marker on the second day or on the second measurement on the successive measurement. You would if you see condition 1 and condition 2 happening together, you would put marker here. On another day or another measurement, let's copy the thing here. You would have another table here which is empty. You would see if the condition 1 is met or the condition 2 is met or not. Assume that condition 1 is met but condition 2 is not met, so you would mark here. You take a lot of measurements like this, 15, 30, it doesn't matter. You would then you would copy the table that you have here and remove the thing. You would have 15 and 30, I don't know, a lot of these, a lot of measurements according to what you're doing, and you would write. I in 14 measurements, it gave this one. 10 measurements, it gave this one, like stuff like that. And you add the frequencies, and you would finally put this in the calculator that I will show later on. Let's give this example. You are doing an experiment, seeing if on the days of that it rains, you the smell is good or not. So did it rain? Yes or not? Did it smell good? Yes or not? Smell good. Let me write smell good so it wouldn't be confusing. Smell good. So you on the first day, you take your table here, you open your window, you see that it's raining, you know that it's raining, and you smell, like you take a whiff and then you smell some good air. Bam, you place your marker here. Let's assume that you do multiple of this multiple times. You do 14. I don't know, 10. I'm just making these values up so that I can do the test. Did it fit? 1, 15, 20, 30. Yeah, 30 for 1 month. You measured, like if it's raining, if it's not raining, does it smell good? Does it smell bad? You place it like this. So let's do the statistical tests. If you this site's link is provided in the description below, so you can click it right there. And let's come to chi-squared calculator. Since we don't have any assumptions, I'm directly going into the calculator itself. So let's change it. Category 1. Rained. Oh no, I did a mistake. Rained and didn't rain. Group 1. Condition 1. Smelled good and smelled bad. So you have two conditions. Let's see. I copy my values here. 40, no, not 141. 1, 5, and 10. I copy my things. Place. I go calculate chi-square test. Thank you. It gives me the p-value. Let's evaluate the p-value here. So I want to write the conditions like the hypothesis for this test. So let's write the null hypothesis so that you can write your own when you're doing your statistical test. The rain and smelling good is not related. Hash one. That's not right. Smelling good. Smell and the smell is not related. Hash one. The rain and smell. The smell is related. So these are my hypotheses. I know that my alpha value is 0.05. I copied my p-value here. If my let's write this a p. If my p-value was bigger than a, it would be accept the null hypothesis. But my p-value is smaller than alpha, 0.05. So I would reject the null hypothesis and accept hash one. The rain it rained and it smelled good or bad, it doesn't matter. The rain and smell is related. So what the outcome is that when it rains, it smells good. When it doesn't rain, it smells bad. And this is a statistically significant finding. Yep. Let's continue. I take two species of plants and I apply the same thing as exists doesn't exist. For this plant and for this plant, I am not going to repeat the process. You can write plant one and plant two is not. Let's assume that you're finding that it is plant one and plant two is not linked. Not linked. What would you say for this? They live together like for something. They probably this one can be leaching from this one, or this one uh, can have a positive relationship with this one. They exist together. So plant one and plant two generally seen doesn't seen together. Hash one, plant one and two are seen together. So hash zero or the null hypothesis is negative one. Is a like a negative connotation one. It's always the null. It's always this is not happening. The thing is not occurring. And according to your p-value, you reject or accept that one. So that seems to be it. So thank you for listening. We'll continue with our next video.